Okay, today's lesson is on algebra's classic game, which is just solving for x, or trying to find the x. What we need to remember is that when we have something, say, in this form, when this equals 0, what we're saying is that x plus 2 equals 0, and also that x minus 3 equals 0. If we wanted to solve for x, we would get two answers. This would generate that x equals negative 2, and this would generate that x equals 3. Again, we call these factors, or we call these the numbers that will make the polynomial go to 0. When we're actually solving for x, what we're saying is that x equals negative 2, or x could equal 3 for this polynomial. We need to remember this idea. The first few problems will be very simple ones, such as x squared plus 2x plus 1 equals 0, and we have to say solve for x. The way you'd want to do that is by factoring. You'll get x plus 1 times x plus 1 equals 0. That means x plus 1 equals 0, and x plus 1 equals 0, or that x equals negative 1. We got the same factor twice. So x would equal negative 1 for this. However, we've been dealing with rational functions, okay? Rational functions. Rational, which means we have a ratio or a fraction between two functions. So the big function is equal to a function divided by another function. Rational function. Okay, so we need to learn how to solve for x dealing with a rational function. Okay, these have a very specific order in which you want to do things. I've written the list here. You want to go ahead and put these in your notes. We want to clear the special x's, look for special x's, determine what they are. Clear the denominator, we'll get to that. Then solve, and then discard extraneous solutions. Extraneous solutions are extra solutions that don't actually make the problem true, and I'll show you how to determine those. Okay, so this is one type of problem you guys might see on this section. What we have is the fraction x divided by x minus 2 plus 2 divided by x plus 3 equals, here's the big change, is the equal sign, 10 over x minus 2 x plus 3. The first thing we want to do is look for special x's. So again, we're asking what values of x will cause the denominator to go to 0. The special x's we have to worry about here are x equals 2 and x equals negative 3. Negative 3 will make this one go to 0, and x equals 2 will make this one go to 0. The next thing we want to do is clear the denominator. So to clear the denominator, we're going to come over to the answer here, and we're going to get rid of this x minus 2 and x plus 3. The way we're going to do that is by multiplying by x minus 2 and x plus 3. However, if we multiply on one side of the equal sign, we have to multiply by the same thing on the other side. So we're going to multiply both these factors by x plus 2 and x plus 3. Okay, by doing this, certain things are going to happen. First of all, we are going to clear out the denominator on the equal sign, and we'll be looking at something that equals 10. On the other side, we have some cool stuff going on. When we multiply this chunk to here, oh, I wrote that wrong. That's minus 2. Minus 2. When we multiply this, the x minus 2 is actually going to cancel out. So all we're really looking at is x plus 3 times x. We have a plus sign here, so plus. And then we have to do the x minus 2 times x plus 3 to our other component over here. And the x plus 3's will cancel out. So what we're left with is x minus 2 times 2. We're now looking at no denominator. or denominators of 1, whichever way you want to think of it. And this is actually a lot easier to solve than what we were looking at previously. Now we just have simple multiplications that we have to complete. So x times x is x squared. 3 times x is 3x. 2 times x is 2x, and 2 times negative 2 is negative 4. And this all equals 10. So now we can start to solve. We have x squared plus 5x, and I'm going to do this quick. This subtracts over to minus 14. From here, we need to factor or solve for what will make zeros. Let's see. It looks like I'm going to have 7 or x plus 7 and x minus 2. Oh, this equals 0. This still equals 0. Okay, we're in the solve part of things. This is 3, so we're solving. So it looks like my answers are x equals 2 and x equals negative 7. Okay, once we're here, we have one last step. We have to discard the extra solutions or the extraneous solutions. What we do to do that, we check our special x's with our solution set right here. It looks like I can't let x equal 2. That's what my special x's are telling me, is x cannot equal 2. Therefore, on my solutions here, I have to come out and I have to take out this x equals 2. It turns out that is not a solution. And the only solution we actually have is x equals negative 7. That is the answer. If you guys have any questions or comments, please let me know.